Evening, folks. Brian here, Geomagnetic Earthwatch, Friday, June 6, 2025. A short talk this evening on volcanic eruptions and whether or not we can accurately forecast if and when in the timing of volcanic eruptions. This video clip is the Tonga Haipe eruption in January 15, 2022. That was a large submarine eruption. Now, Tonga Haipe volcano is right here, north of Tonga proper, Fiji. So the thing is, folks, for 12 months prior to the eruption, I was monitoring and documenting heat detections prior to the eruption. That was 12 months. And in fact, it was showing some signs even before then. This is January 5, 2020, so 2 years prior to the eruption. It was showing heat. I picked up on it 12 months before. Next, we're going to jump over to La Palma's Cumbre Vieja volcano. The large eruption in September 19, 2021. I was watching and monitoring heat detections for, there's either 30 or 31 days prior to the eruption. These ones were on the 17th, so 2 days prior. I'm just going to pick a few days here. So the 15th, running a bit slow here. Let's go 7 days from the 13th. This is Tenerife. So again, this is just a few examples. This was before the eruption. So 30 or 31 days notice prior to the eruption. Two years ago, there was a notice put out for one of the volcanoes in Alaska, southern Alaska. It's actually off the coast of British Columbia, Mount Edgecomb. They were sending an alert notice out for the nearby community to get ready for a possible evacuation. And this one would be, here we go. So southern tip of Alaska. On Edgecomb. And now, of course, we have in Alaska, Mount Spur. They've been warning people the possibility of getting ready for a major eruption. And then finally, the axial seamount. So this is not new news. It is old news, people. They have been saying for the past several years that by the end of 2025, the axial seamount is going to erupt. In fact, they have a sensor array to monitor the inflation deflation around the mount, connected by cables. Oops, sorry for the sound. So here's one of the arrays. So what I'm trying to get at is that there's really no accurate forecast method to determine when a volcano will erupt. Tonga, Hape, showing heat for at least 2 years before it went off. On the other hand, La Palma, only 1 month before it went off. They issued warnings for Edgecomb volcano 2 years ago. Nothing's happening. So far, nothing happening in Mount Spur. My question is, how can they be so adamant, assured that there's going to be an eruption of the axial seamount off the coast of Oregon by the end of 2025? So when you're looking at volcanoes, I mean, here's another thing. These other people out there on YouTube. You may have an earthquake swarm at or underneath a volcano. It doesn't necessarily mean there's an imminent eruption going to take place. Like, for example, whenever there's a magnitude 5 earthquake in the middle of Iceland, someone gets on the air because she used to live down there and they say there's an imminent eruption. It's going to happen. No one knows that. No one knows. Campi Flegrei, for example. Campi Flegrei does fall in with the 3,600-year timeline. Yes, there's lots of earthquakes, felt reports, deformation, buildings cracking, smell of gases, etc. That can go on for another 5 years, or it can go off tomorrow. And this is the issue that the government has, for example. Do we order a mass evacuation of 1 million plus people? Nothing happens for a year? And so on. Now, on the other hand, when I showed you the heat spread on the southern shores, inland, southern Sicily, then in 3 to 4 days later, Etna blows its top. More than it usually does. That heat spread suggested rising magma, perhaps from a magma reservoir on its way to feed the magma chamber for Etna. 2 years, at least 2 years of heat, 4 days of heat, 30 days of heat. Warnings issued, nothing happens. Mount Meager, which is a volcano on the outskirts of Vancouver, on the outskirts of Whistler, it's been outgassing for years. The universities there have their sensors set up there, monitoring it. So, you know, we don't know. I think one of the key things, obviously, is the weakening of our protective magnetic field, allowing increased levels of cosmic radiation coming in, the highly charged particles. So I just wanted to show you, give you an example how we don't know when something's going to go off. Okay. A lot of people have eggs on their faces right now. A heightened state of awareness should still be issued so people in those areas can make their own decisions. Do they move away or they stick around? And I think that's the best approach right now. The earthquake swarms, Santorini, Mediterranean. Last time I checked, it was 17,000 earthquakes. Now, Santorini certainly does fall in within the 3,600-year timeline. Last time, the Minoan eruption, 3,625 years ago. We just had this massive earthquake swarm, but it's spreading now. It's going to the south. Nothing's happened yet. It's not an exact science. And YouTubers, especially myself, we don't know when. I can just tell you what I see happening. Oh, by the way, one more thing I want to show you. So I reported the heat detection on the continental shelf off the shore of Massachusetts. This is about the, I don't know, 4th, 5th, 6th time in this particular spot. This detection point shows up. I believe there's 4 of them. 5. Coincidentally, there's also an algae bloom in the area. So from, among other reasons, algae blooms can be formed from a warming of the waters, as well as an introduction of such things as nitrogen, which is one of the volcanic gases. Nitrogen and phosphorus. Phosphorus is not known to be emitted from volcanoes. From the ash of, yes, but not necessarily from volcanoes' gases. So our So our heat detection is pretty much in the middle of this algae bloom. So there you go, just an observation. So I already explained my idea, my theory about the outer core expansion, right? When it expands, that pressure has to be exerted, it has to be escaped up through the mantle plumes to the underside of the lithosphere, and then we're going to have all these heat detections all over the places. Quite concerning, not quite alarming, but quite concerning when you start seeing heat at subduction zones. California, Northern Pacific Plate, Kuril Islands, subduction zone, Arabian Sea, triple junction, fracture zone, etc. So the heat is rising. Sometimes it does, like Etna, result in an eruption. Other times not. Okay, that's going to be it for now, as it were.